Alrighty, so welcome back, and today we are going to be covering how to solve equations that have absolute value and roots inside of them. So it's actually not too bad, but before we get to that, let's actually do the homework. So the first one was we had x minus 7 quantity squared plus 1 equals 10, and I asked y'all to solve that using the square root method. So what do? Well, number one, we have to isolate the square part. So I'm going to subtract 1 from both sides. So I'll get x minus 7 squared equals 9. Then I'm going to take the square root of both sides, but it's the verbal square root, not the principal square root that would be dictated by use of the symbol. So square root of both sides will since the square root is the inverse of the square, we will cancel the square and we'll be left with x minus 7 equals plus or minus square root of 9. And so x minus 7 equals plus or minus 3. Now I can solve for my x plus 7, and I get x equals 7 plus or minus 3. And that's it. Not too bad. Alrighty, so let me erase this. Let's tackle number 2. So number 2, we're going to complete the square. And so we had x squared plus 12x minus 4 equals 0. And so completing the square, the first thing you do is you move the number over to the right and leave the space alone. So it's going to be plus 4 plus 4. And, well, that's weird. Bar, but that's okay. So I get x squared plus 12x equals 4. Then I take the number that's in front of my x, my b, if you will. I half it, so 12 divided by 2 is 6. And then I square that value. 6 squared is 36. Then I add this value to both sides. So plus 36 plus 36. So x squared plus 12x plus 36 equals 40. Now this is going to form a perfect square. The two factors are going to be the same. In this case, it's going to be x plus 6 times x plus 6 equals 40, which means I have x plus 6 quantity squared equals 40. Take the square root of both sides. Now I can use the square root method. So I take the square root of both sides. I'm going to get x plus 6 equals plus or minus square root of 40 minus 6, and then I am left with x equals negative 6 plus or minus root 40. And I'm totally fine with you leaving it like that. Alrighty, hopefully that went well. And I definitely hope the next one goes well. That's the quadratic formula, so let's knock that one out. So with quadratic formula 1, we had, for number 3, 2x squared plus 5x minus 3 equals 0. Alrighty, what's my A, B, and C? I've got them all moved to the left so now I can fill that out. So A is 2, B is 5, and C is negative 3. Also want to make sure I put down the formula. So x equals negative b plus or minus square root of b squared minus 4 times a times c, all of that divided by 2 times a. Okay, so I can set that up now. X equals negative b, so negative 5, plus or minus the square root of 5 squared minus 4 times 2a times c, negative 3, all of that over 2 times a, so 2 times 2. Okay, so I can now kind of move through it. So that's negative 5 plus or minus. I'm going to have, for this, 5 squared is going to be 25. And then negative 4 times 2 times negative 3 is going to be positive, what is that? 8 times 3, 24. Okay, and then all this over 4. So x is equal to negative 5 plus or minus the square root of 25 plus 24 is 49 over 4. And then we'll have x is equal to negative 5 plus or minus square root of 49, 7 over 4. And you can leave it just like this. I'm totally happy with this. So there we have it. That is how you can solve quadratics. 3 different ways. As I've said in the last video, I personally prefer completing the square. It's my favorite of all the methods, but I do realize that this one works for every one of them, and completing the square, you have to have those special circumstances we talked about. So, anywho, alrighty, so now that we've gone over that, let's talk a little bit about, let me clear the screen, and let's see, let's talk about solving equations with square roots and absolute values, okay? So the first thing we're going to do is solving equations with square roots. And this one could not be easier. So let's say I have something like square root of x plus 1 equals 5. So just like when we were solving equations that had, when we were doing the square root method, where it had a square that we were trying to isolate, if an equation has a root in it, we also want to isolate it. So in this case, if the root is already isolated on the left, the second that's isolated on the left, all we do is we square it. And since we do it to one side, we have to do the same thing to the other side. The square is going to cancel the root here and leave x plus 1 equals, and then 5 squared, 25, and then I can solve minus 1, x equals 24. Okay? That's it. It could not be easier to solve equations with roots in them. So let's do some others. Maybe I'm trying to make something complicated, but it's just really not that bad. X minus 2 minus 3 equals, I don't know, 2. Okay? So first thing I want to do is isolate the root on the left. I do that by adding 3 to both sides. And I get root x minus 2 equals 5. Now that the root is isolated, I square it. But I also have to square the other side, so I wind up with x minus 2 equals 25 plus 2 plus 2, x equals 27. And there you go. There is one type of root that is a little more complicated. It's not horrible, it just has a lot more steps to it. So let me show you that one. Clear this. Clear this. Alrighty, so what if I had root x plus 1, I'll just go ahead and put it in this form first, equals x minus 3, for example. Okay? So with this example, I have the root isolated, so I want to square this side to kind of undo the root, but then I have to square this side. And I square the entire side at once. This does not become x squared minus 9. That is not what you get from here. You have to square x minus 3 as a quantity. So you wind up with x minus 3 times x minus 3. You have to multiply it all out. So let's go ahead and do that. If I have this and I square it, it undoes the root. So I wind up with x plus 1 equals, now over here, I'm going to have, let's see, x squared minus 3x minus 3x plus 9. So x squared minus 3x minus 3x plus 9. Alrighty, now I can combine some terms over here. I get x squared minus 6x plus 9. Okay, so now what I'm going to do is move everything over to this side. So if I do let me say how to say that. Unfortunately, it's on the wrong side that I like to work with. I like to work with my X's on the left side. It's just a thing. So if y'all are okay, I'm going to like flip this around so that I can work with it that way. It's just me. There's no difference when doing it the other way. I just enjoy that. So if I subtract X, I'm going to wind up with X squared minus 7X plus 9 equals 1, minus 1, minus 1. So now I'm going to get X squared minus 7X plus 8 equals 0. And now that I've got it in this form, I can solve it. So everything has been moved over to the left, and now I can solve it. So I've got X squared. It's just solving a quadratic. So that's what it is now. So when I solve that, I can actually, this will factor, which is kind of surprising because I just made it up out of thin air. If I do, no, it won't factor. I thought it would, but it won't. Nope. We're going to do quadratic formula for this one. The B term is not even, so I can't do my favorite, completing the square. So, oh well. Let's do quadratic formula. So A is 1, B is -7, and C is 8. So X equals, we're going to run out of room, I can already see this. X equals -7, so 7 plus or minus square root of -7 squared is 49, minus 4 times 1 is 4, times 8 is 32, and then all of that over 2 times 1, 2. I just condensed it so that I wouldn't run out of room. So here's X equals 7 plus or minus square root of 49 minus 32 is going to give me 17 over 2, and that's as good as I'm going to get. It's not going to condense down any lower. So that's the only wrinkle to solving roots, is that sometimes when you square the other side after you've isolated the root on the left, you actually wind up with a quadratic. If you have an X over here, you're going to wind up with a quadratic when you square it. And the only other thing to remember is that you square the entire side, not the individual terms. You do not square the individual terms. You square the entire side, x minus 3 times x minus 3. And that's it. That's how you solve roots. So hopefully that wasn't too bad. And we can move into the next topic. So let me clear this and let's get going. Okay, so now let's solve equations with absolute value. I wish I could say this is as easy as solving the equations that have roots in them, but it's not. It's actually a little more complicated. It's not bad, it's just more complicated. So let's say I had absolute value of x. Well, you know what? Before I do the absolute value of x equals something, what's the absolute value of -2? Yeah, it's +2, right? Absolute value takes whatever's inside of it and it makes it positive or 0. So if there's a negative sign there, that negative sign goes away and you wind up instead of -2, +2. You can never have a negative value result from taking the absolute value of something. So that's a good thing. That actually makes your life easy in a lot of situations. But for this right now, if we are just talking about solving these equations, the fact that it does this behavior makes things a little bit weird. Let me explain why. Let's say I have absolute value of x equals 2. What could x have been to equal 2? Well, x could have been +2, but it could also have been -2. Both of them would have resulted in an answer of 2. So with absolute value equations, you have to split the equation into 2 pieces. I'm going to write that down so that people can remember it. So with absolute value equations, you need to split it into two pieces. Exclamation point, exclamation point, exclamation point. I wish I could put this whole thing with lasers flashing out of the screen and some loud popping noises, something, because this is one of the most commonly missed things in all of algebra, is how to handle an absolute value equation. Absolute values aren't like normal equations because in the process of ensuring that what comes out of here is positive, you wind up with two possibilities. The stuff inside was positive or the stuff inside was negative. So you have to split an absolute value equation into two pieces. And I apologize for my writing yelling this out, but this is such a critical thing that people miss all the time. So let me give you an example of what I mean by splitting it into two pieces. Let's say that we have absolute value of x plus 1 equals 3. Okay? What things could I add 1 to inside this absolute value and get 3? Well, if x is 2, that would work. 2 plus 1 is 3. But it would also work if x is negative 4. Negative 4 plus 1 is a negative 3. I then apply the absolute value. The negative 3 becomes a positive 3. So we need a method to be able to yield these two very different answers when we see an absolute value. And although what I just said was that this interior could be positive, it could be negative, but when the absolute value is applied, you get it positive. Although I said it that way, there's an easier way to solve it that most people prefer, and that is to break the absolute values into two equations, like so. The first way is you take this is going to be for assuming the stuff inside was positive. So I break it into this equation over here by copying everything exactly like it is with no change, but no absolute value either. X plus 1 equals 3. Okay? The other way I can break this into two pieces is by taking what's in here, x plus 1 equals, and changing the sign of everything that's out of the absolute value, negative 3. So to go over that one more time, the first piece I copy down as is. The second piece, everything that is outside the absolute value, this and anything else that had been over here, you change the sign of. So the positive 3 becomes a negative 3. Now I solve like normal. Minus 1, x equals 2. Minus 1, x equals negative 4. And those are the two solutions that we thought of above. So if you split it into its positive piece, if you will, copy it straight down, no changes. The negative piece, you change the sign of everything that's over here, that's outside the absolute value. Okay? So let's knock out a different example. How about absolute value 2x minus 1 equals 7. Okay? Well, let's break it into its two pieces. First piece I'm going to copy down untouched. 2x minus 1 equals 7. The second piece, I'm going to change the sign of everything that's outside the absolute value. So 2x minus 1 equals negative 7. Plus 1, I get 2x equals 8, divide by 2, x equals 4. Over here, plus 1, 2x equals negative 6, divide by 2, x equals negative 3. Did it work? Well, let's check. 2 times 4 is 8, minus 1, 7, absolute value 7, 7. That one worked. Now let's try negative 3. 2 times negative 3 is negative 6, minus 1 is negative 7, absolute value negative 7, positive 7. It worked. Alrighty, let's do another one. Clear this. So what if I had the absolute value of, I don't know, 3x minus 4 equals negative 1. Okay, well, I could just start off by breaking into its two pieces, or I could look at it really carefully before I do anything. Notice anything odd about this? The absolute value of this thing is equal to a negative number. The second you see that, it is no solution, because the absolute value can never yield something that's negative, ever. So before you break it into its pieces, check to see if the absolute value part is equal to a negative number. If it is, you're done. You don't have to solve anything. No solution, move on. I won't say that I would try to trick you with this on an exam, but it might show up, because this is something that you will see not out and about in the wild, because this doesn't generally happen in the wild. I can count the number of times I've seen absolute value in the wild, probably on the fingers of both hands. But it's just mathematically, it is a kind of like a sanity check that you do whenever you're working equations, is to not get bogged down in the details at the very beginning. At the very beginning, you should just look at the equation and kind of do, does this make sense or not? If it doesn't, why doesn't it? Can I just do no solution? This case is one of the cases where there's no solution. We would have had the similar thing if we had said the square root of x plus 3 is equal to negative 2. What can I take the square root of that will give me a negative number for an answer? Yeah, not a lot. So there you go. When I say not a lot, you can't. You can't take the square root, which, what do I multiply by itself to give me a negative number? It would have to be imaginary. So that's another thing to kind of look out for, but I digressed on that one. The big thing, though, that I really want you to always notice is this. Absolute values can never, ever, ever equal a negative number. The second you see that, you're done. Okay? So now that I've said that, what if I have absolute value of 3x plus 4 equals 5? I'm going to break it into its two pieces. 3x plus 4 equals 5. And then 3x plus 4 equals negative 5. Alrighty, so I'm going to subtract 4, wind up with 3x equals 1, divide by 3, x equals 1/3. Okay, over here, minus 4, 3x equals negative 9, divide by 3, x equals negative 3. And if we plug those in, it'll actually work. So, not too bad. Alrighty, so we've done how to solve the root equations, the equations that have roots. Now we've tackled equations that have absolute value, but I haven't done all the absolute value equations yet. So let's move on to a few more complicated examples. So let me clear this and let's get going with that. Okay, let's see. What if we had absolute value of x plus, oops, let me make that a little bit bigger. We'll make the x that big. X plus 4 minus 3 equals 5. Okay, well, before I break it into its two pieces, I need to isolate the absolute value on the left side. So I'm going to add 3 to both sides. Absolute value x plus 4 equals 8. I find it highly comforting that to solve roots, squares, or absolute values, you isolate the thing on the left side before you do the whatever process that you need to do to it. So now that it is isolated, I break it into two pieces. So for the positive piece, I copy it down straight as is. And for the negative piece, I change the sign of everything that's outside the absolute value. So negative 8. So then I solve like normal. Minus 4, x equals 4, and minus 4, x equals negative 12. Alrighty. Does it hold? Well, 4 plus 4 will give me 8, which when I take the absolute value is still 8. 8 minus 3, 5. That works. Negative 12. Negative 12 plus 4 is negative 8, but when I take the absolute value it's positive 8. Positive 8 minus 3 is 5. It works. So there you go. That's how you solve them, and you can get a little more complicated, but you wind up when you start playing around with absolute values and doing these assumptions of breaking it into two pieces, you can run into some trouble with solutions that aren't actually solutions. So I try to avoid those in practice. I just like to mention them. If I solve this equation with 3x plus 1 equals x plus 2 and 3x plus 1 equals negative x minus 2, then I solve it. So I'm going to move the x over. 2x plus 1 equals 2, minus 1, minus 1. 2x equals 1, divide by 2, x equals 1 half. Okay, now I do the same thing over here, plus x, get 4x plus 1 equals negative 2, minus 1, 4x equals negative 3, divide by 4, x equals negative 3/4. Now I'll plug them in. Plug a half in here, I get 3 halves plus 1. Well, 3 halves plus 2 halves is going to be 5 halves. And then 1 half plus 4 halves is also 5 halves. This one checks out. I plug this one in, though, it's a different story. Negative 3/4 times 3 is negative 9/4, plus 4/4 is going to be negative 5/4. Okay, so wait, did that work right? Let me make sure I did that right. Negative 9/4 plus 1, and then absolute value of that equals negative 3/4 plus 2. Okay, so this is going to be negative 9/4 plus 4/4, which is what that would work out to be. And so that would be negative 5/4 equals negative 3/4 plus 4/4 per thing, so 8/4 equals 5/4. That should have been a 4. No, that's not a 9, I promise. Negative 5/4 equals positive 5/4. Yep, that's not right. So what that means is that this is an extraneous solution. An extraneous solution. And it kicks in because we have an x outside and an x inside the square root. So the absolute value. So when we wind up making the assumption of breaking them into two pieces, we kind of put some restrictions on the values that wind up having it kind of it makes it so where that the two answers won't coincide when I plug them in. The left side and the right side will be different answers, different in sign. So I don't tend to try to trick people with these. I just show it to them and say that when you're dealing with absolute values and you have variables on the outside and the inside of the absolute value, check your answers because they may not all work. This actually comes up as you go up in math. It happens more and more frequently where you do all the right steps and yet the answer still turns out to be impossible. So that's just the way it goes sometimes. But the ones you're going to see on the exam look like this. They are the nice absolute values, just numbers on the outside so we don't have to worry about anything going wonky like it does over with these extraneous answers. So this is what you'll see on the exam. And that's about it. That's about as bad as it gets. So let me give you your homework. I hope this wasn't too bad. I'm trying to break the last bit off into tiny bite-sized pieces. We've got one big thing left to do, which I'll kick that video out tomorrow. And when I say it's a big thing, it's not a huge thing, but it has some things in there that are important. So here we go. Let me clear the screen, give you your homework. So homework is going to be 4 problems today, but I'm only going to star 3 of them, which means, of course, you don't have to work them if you don't want to, but I think it would be a good idea. So first off, let's go with number 1. Going to be absolute value x plus 2 equals 7. You know what? Let's do 6 problems, and I'll star 3 of them. I like that. Number 2 is going to be the absolute value of 2x minus 3 equals 4. And number 3 is going to be absolute value x plus 5 plus 4 equals 1. And I want to star this one and this one. Okay? For 4, let's go with root x plus 1 equals, let's try 3. Number 5, let's go with, root 2x plus 4 equals 7. And finally, for the 6th one, root, let's go with x plus 5 minus 3 equals x. Start this one. So this one, and this one. Remember, you always break your absolute values into 2 pieces to solve after you isolate them. And for the roots, isolate the roots, square both sides, and if the side that is not the root has 2 terms, you have to square the whole thing. Maybe 6 looks something like that. So good luck with it, and I will see y'all tomorrow. Take care. Bye-bye.